Welcome to the Journey Chez Cam. Well, we're going to see if you were taking notes yesterday and paying attention. So please do the 2 warm-up questions to the best of your ability in your composition notebook, and we will discuss them in a moment. In number 1, I am given a table of different things to complete. And we need to understand the terms that we were discussing yesterday. You may want to go and review that if you don't remember. Well, the Z is the atomic number. The A is the atomic mass. P is for protons, which is the same as the atomic number, and N is for neutrons, and E is for electrons. Now, the first isotope that we have here is barium-138. The top number is the mass, and you'll remember that the mass is the atomic number plus the neutrons is equal to the mass. And therefore, my atomic number here is 56. I'm going to write 56 here because that allows for an easy subtraction. This top number is the Z plus the neutrons equals that number. And therefore, my atomic mass is 138. My number of protons is the same as my atomic number. My number of neutrons is the difference between these numbers. And when I do the math, I get 82. The number of electrons is the same as the number of protons because I don't see any charges here, and we will discuss them a little bit later so that you become familiar with that. And therefore, this number would be 56. Iron, this isotope of iron has an atomic mass of 56. Its atomic number, when we look that up, is 26. And I'm also going to write it there for my subtraction to make it simpler. When I subtract these numbers, I get 30 neutrons and the same number of protons. The atomic number equals the number of protons. And the number of electrons also equals the number of protons in this neutral atom. Scandium here, the atomic number for scandium is 21, and therefore it has 21 protons. Its atomic mass was given as 44. The number of neutrons is the difference between the atomic mass and the number of protons, and that would be 23. And then we have 21 electrons and as well as protons. Now, in this case, we're not given the actual atom that we have, and therefore I'm going to add the atomic number plus the number of neutrons to get the mass of this element. And the mass then is 128. And when I look at its atomic number, I can tell which element it is, and it is tellurium. Atomic number 52. The number of protons is the same as my atomic number. I'm given my number of neutrons, and my number of electrons is also 52. And that's a little bit of review from yesterday's discussion. And I'll be right back. In number 2, we are given some atomic numbers, and all we have to do is look for those atomic numbers on our periodic chart. Atomic number 19 is potassium. Atomic number 3 is lithium. Atomic number 15 is phosphorus, and my all-time most favorite, number 79, is gold. And that's how you do number 2. Now, we are going to take a few notes, but what I would like for you to do is copy the problem that you are given next, and we will come back and discuss it. Let's talk about average atomic mass. When we look on any periodic chart, we see that the masses are decimal values. They are not exact. And every isotope that we've had so far is always an exact number of protons plus neutrons. And we need to learn how we come up with those average atomic masses. Well, I'm sure that you copied the problem that you were given. We have two isotopes of chlorine, and we are given their relative abundance, and it says respectively, which means that it is given in order that it occurs. The first isotope is given this mass, and we multiply it by the percentage in decimal form, and we were given 75.33%. And to change that to a decimal, I divide it by 100, and that will give me the decimal form of that percentage. I use a 0 just to set off that decimal. Then, whenever we do calculations for the remainder of the year, we will always take it 4 places past the decimal and cut it off. That's called truncating. But we don't need to use that big word truncate. We're just going to cut it off. Then we have the second isotope of chlorine, and its relative abundance is 24.67%, which I changed to a decimal, and I multiply that together. Now, the reason that I add these two together, because I'm getting an average, and students always want to divide by 2. But this is like a pie of all of the isotopes that exist. And 75% of them have one mass, and the other is approximately 25% of those two. Therefore, to get the whole, I need to add those two numbers together. And in my calculation, I always take it 4 places past the decimal. Now, for the remainder of the year, we are going to take the masses that we get from the periodic chart or that we calculate, we are going to round them to the tenths place. And 5 and above will round up. And therefore, this 6 is rounding the 4 up. And my final answer is 35.5 atomic mass units. That's what AMU stands for, atomic mass units. Or I could also use an abbreviation of just U. And that's how we determine the average atomic mass of an element, by using the relative abundance of the isotopes that exist in nature. The next thing that I need to talk to you about are ions, and I'm sure that you are probably familiar with this, but we need to review it to make sure that you understand. Well, ions are elements that have either gained or lost electrons. An element that gains an electron becomes negative. Because electrons are negative. And so if it gains electrons, it's going to gain a negative charge. Elements that lose electrons become positive. We've taken away that negative charge, and therefore we've taken away that electron that's negative, and therefore the element becomes positive. This will be used throughout the year. It's very, very important that you remember what happens. And electrons are negative, so sometimes it seems a little bit opposite of what we would think. Well, let's look at some examples. If I have the fluoride ion, fluorine with a -1 charge, I look at its atomic number. And its atomic number is 9, which means that it has 9 protons and 9 electrons in the neutral atom. But this atom has gained 1 electron, and therefore it has 10 electrons. It's possible to gain 2 electrons. Sulfur may have a -2 charge. It has an atomic number of 16. And therefore, it has 16 protons and 16 electrons in the neutral atom. And therefore, we gain 2 electrons and we have a total of 18 electrons in this ion. When we lose electrons, we get a positive charge. And sodium will have a +1 charge. Well, sodium's atomic number is 11. If it loses 1 electron, it becomes 10 electrons. We may have aluminum that has a +3 charge. And aluminum's atomic number is 13. And therefore it has 13 protons and 13 electrons in the neutral atom. Well, when it loses these 3 electrons, we are left with 10 electrons. And that's how you determine the number of electrons that various ions will have. And that's what we have for today. And I can't wait to see you tomorrow. Bye.